practice test for tomorrow's chapter 2 test. Consider the function -10. Now I'm going to go and write this on my line paper. Write it in the space if you haven't done anything with this yet. I'm hoping you have. The reason why I'm going to rewrite it is I want to be able to put arrows and things pointing at what all the different parts of the equation do for us. Now this was from section 2.1, where we've got all of our ideas about reflections, translations, all that good stuff. There are multiple parts of this equation that there's multiple parts we have to address. What can I do for you? First of all, what I know is that this negative sign right here, sitting outside, is going to create a reflection over the x-axis. Reflection over the x-axis. I'm not even going to my calculator for this. I'm asking you guys to look at the equation, go back to what you have for your 2.1. What do all these different things do? Now, the one page I thought was super useful for something like this is where? Right within our notes, actually. Write the stuff within our notes packet. Like I'm looking at on our notes packet, I have examples of how this would look in an equation. We've got these examples of how things look and how they act. What happens when we perform these stretches and shrinks? What goes on? Now this 10 right up here, speaking of stretches and shrinks, this 10 right up here is going to make the parabola, now I know the parabola is reflected over the x-axis, but it's going to make it skinnier. It's going to make it skinnier. It's going to be reflected over the x-axis. The parabola gets skinnier. We call that a vertical stretch when it goes towards the x-axis. The 10 makes it stretch vertically. I actually just put vertical stretch of A equals 10. Then the stuff that goes on the inside, this is actually in vertex form. Vertex form is when we have that A. Vertex form is A times x minus h squared plus k. The reason I bring that up is because the vertex sitting at that, the vertex is at 5 and 7. And that actually tells us what would have happened to the parent to get it there. Well, what happened to the parent in this transformation. And the 5, x minus 5 inside, would be moves the vertex to the right 5. Oh, shoot. Horizontal translation, I should have said. Horizontal translation. Horizontal translation, right 5. Then the plus 7 at the end is a vertical translation and takes the parabola up. Yeah, vertical translation. Now remember, hold on a second, vertical translation up 7. What's happening on the outside, if it's positive, it goes up. If it's negative, it goes down. But it's when we pull stuff out of the inside that it does the opposite. When it says x minus 5, it moves to the right. If it said x plus 5, it would move to the left. So identifying all the parts. Second question here. Second question, we've got a transformation of a figure, or we've got a transformation of a graph. Now, what I'm going to ask you guys to do first of all is let's go put x squared into y1, because that's the function that we have to start with, and then we have to do a bunch of stuff to it. So we'll use our calculator through this. Not going through the calculator motions today is really, really silly. You absolutely want to go through all the calculator work just to be sure. All right, I'm writing it as y equals x squared, but just to be sure that you've got this down for what you're going to be doing tomorrow. I'm putting my x squared in my calculator. I'm just going to hit graph, make sure we all got the same parent. This is the function that we have to start with, x squared. Now, the way the directions are written for this particular problem, it says let the graph of g be a horizontal shrink by a factor of 1/3. Now, what I remember about horizontal shrinks, and I go back to horizontal shrinks, it's page 27 in our notes. When I've got a horizontal shrink by a factor of 1/3, what that means is that I have to multiply by 3 horizontal shrinks and stretches, multiply the input by the reciprocal. So multiply the input by 3 over 1. So my new function is going to be 3x squared. I'm going to go put that into my y2 and make sure that it's done that horizontal shrink. This would also be the same as a vertical stretch. Horizontal shrink and vertical stretch result in the same thing. So 3x squared, and then the question is, did it act? For sure. Horizontal shrink is the same as a vertical stretch. If we put it in as 1/3, it would have got fatter. And that is not a horizontal shrink or vertical stretch. Horizontal shrink because it's going away from, it's the one inside, it's going away from the x-axis. Now, translation 1 unit up. Well, this came up in our last one. Translation 1 unit up, that was page 26 in our notes. Yeah, vertical translations. And we just dealt with one of those. To get a vertical translation up, we just add 1 on the outside. Now, I'm going to go into my y2 and just add in that +1. Does it actually move up 1? Going into my y2 and adding in +1. Does it actually move up 1? They wanted me to call this function g, so as I end, I'm going to just write it as g of x equals 3x squared plus 1. And again, I cannot stress the importance of going through the motions on your calculator right now. Get your phone away, get your calculator now. Try it in your calculator. Does it do the same thing? I'm going to guess it's a little bit diff. Get up and get your calculator. Use it then. So problem number 3. Now with this one, we've got a much more in-depth function that we're starting with here. The opposite of x plus 3, that quantity squared minus 2. So I'm actually going to go in and let me put this starting function in my calculator. Let's take a look at this together. Then we'll go through the motions of taking care of the translations that it wants. Negative x plus 3 squared. Again, if your calculator is not in your hand, the question is why not? This needs to be like second nature. You do not have extra time tomorrow to try to figure out how this all works. The day is today. Not using your calculator now is what you guys are wasting some time to get some practice here. I need to take my function. There it sits. So my function looks like an upside down parabola over there. This is what we're starting with. So I've got in my y equals right now, the starting point was my negative, or the opposite of x plus 3, all that squared minus 2. The first thing that they talk about doing to this parabola, and then we'll get back to our calculator and see how it works, a translation 2 units up. Well, I know with a translation 2 units up, that just means that I have to add 2 on the outside. And I don't know if you guys see the simplicity in this. You got it. So after I move it 2 units up, I'm actually just sitting right here. Because it was already 2 units down, now it's going 2 units up. It was sitting 2 units under the x-axis. Let me go and rewrite this without that minus 2 plus 2 on the other side, x plus 3, that whole thing squared, with nothing added or subtracted because my 2's just canceled out. And when I look at the graph, there we go, that moved it up 2. So adding 2 on the outside, simplifying that down, I got it translated up 2. Now it also says translate it to the right 2. When we go to the right, we have to mess around with what's inside the parentheses. And when we go to the right, we were just talking about this on the other problem, inside the parentheses means that I actually have to go and put it as a negative 2 inside, because that inside always is the left or right motion. Y is equal to the opposite of, I had x plus 3, I need to also put in a minus 2 now. And that should move it 2 units to the right. So I'm going to go in my calculator. X plus 3 minus 2 is just going to, is going to be x plus 1 squared. And let's see if that, so I've got my, I just got to change my x plus 3 inside parentheses to x plus 1. And then I'm going to go look and see not only did it go 2 units up, it went 2 units to the right now too. Not only did it go 2 units up, but it went 2 units to the right now too. So far so good. Now, last but not least, and this was a weird one. Sometimes the reflection in the y-axis doesn't matter. This parabola where I'm sitting right now is not symmetric around the y-axis. So reflecting it over the y-axis does matter. Now, to get a reflection in the y-axis, what we need to have is we need to make x opposite. Reflection in the y-axis, you need to make opposite x. And so what that means to finish this up then, I've got positive x inside, I need to make it negative x inside. And then this should take, when I go to check out my last one, it should take that parabola where I left. I'm actually going to leave that one sitting right there. I'm going to go put this in y3. Opposite of x plus 1, all that squared. So getting in my 3 steps, I got my translations in y2. Now I'm going to see if it ends with the reflection. Perfect. Over here, I was on to the left of the y-axis, now I'm to the right of the y-axis with my parabola. That's my end game for number 3. I do think that they wanted us to call it like g. I need to change it. G of x. Function g. I'm just going to use function notation. I was going and using y equals simply because we were in our calculators. So problems like that, expect them. Expect them. That's that first couple pages of our notes packet, that first group of problems. Now, when we go to number 4, when we go on to number 4, this problem here, your class council determined that profit from the upcoming dance is directly related to the ticket price for the dance. Well, that makes sense. Figure out how much something costs and how much you're going to bring in. Maybe the more you charge, the more you get, but who knows. Looking at past dances, the council determined that the profit P can be modeled by the function P of T, profit of tickets, is equal to negative 12T squared plus 480T plus 30, where T represents the price of each ticket. Well, I'm going to first come in and I'm going to just make X's on here because in my calculator, so profit based on X, my calculator doesn't like T's, it just wants X's. So wherever I see a T, I'm going to put X. What should be the price of a ticket to the homecoming dance to maximize the council's profit? Well, we need to find out then, what's the maximum value of the whole function? Where does it hit its max? And actually, if over here is going to be the tickets, I actually just need to find out tickets, and this is profit on this side. I just got to find out what's the maximum number of tickets, and I can find that maximum in standard form if I identify my A, B, and C values and use the idea that X value of the vertex is the opposite of B over 2A. So since this is in standard form, I'm looking for you guys to go find this maximum X or T using this formula. Go ahead. I just rewrote it and put X's in place of T. My A is negative 12, my B is 480, my C is 30. So, and remember again, X is representing the number of tickets. The answer to the question, the price of tickets, I mean, and the answer to the question needs to be, what is that maximum price of tickets? So that's going to be the opposite of, up top I'm going to put 480. That's my B value. In the bottom I'm going to put 2 times negative 12, 2 times the A value. That's going to be negative 480 over negative 24, and that works out to be 20 bucks. So what's the maximum ticket, what's the ticket price where you can maximize your profit? It's going to be at $20. This is the X value of the vertex of this. This parabola goes up and down, and it hits that $20 mark where the highest profit's going to fall in. Standard form equation, you can solve that by X equals X equals the opposite of B over 2A. That came up on standard form. Where do we see this? That's on page 29 in your notes. What I did here was related to what's on page 29 in your green notes packet, if you want to look back at that. Now, problem 5, a biologist took account of spotted trout that migrate to the south end of a lake during winter months. This table shows the population count at the south end of the lake after week 10. Explain why a quadratic function models the data. If we're going to show that, we've got to analyze the table. How are my x values changing so I can go analyze the table? Yeah, as long as my x values are constant, x is +2 constant, I can go on and analyze the y values and start looking for, if it's quadratic, explain why it's quadratic. Well, then what I can do, I'm cool with you showing too, explain or show. If a function is quadratic, its second differences of the y's are constant. And so what we want to do is start out over here and say, how do I get, like, working backwards? What's the 185 minus 209? Go on your calculator and find it. How much? Minus 24. What about 209 minus 217? Minus 8 or 18? 8, okay. How about 217 to 209? Plus 8, okay. And remember, I'm just undoing. I'm going backwards and undoing. Now, how about the 209 minus 185? Okay. These first differences aren't constant, but I have the feeling this is quadratic. Explain why it's quadratic, so I got to go to the second differences. And if I can show the second differences are constant, then I'm good to go. How do I get from negative 24 to negative 8? Negative 24 minus negative 8. This is negative 16. Negative 8 minus 8. There's negative 16 again. Positive 8 minus 24. There's negative 16 again. The second differences are constant. That's what makes it quadratic. The second differences are constant. Now, it says write an equation to represent the information. I'm going to suggest anytime you guys are sitting here in this write an equation to represent the information, let's go into our stat edit and drop weeks in list 1 and population in list 2. Let's do it. Let's do it. So in our calculator, oh, I'm going to clear out my y equals before I do anything else because I'm going to come back to this. Stat and edit takes me to my list. To clear a list, go to the top, hit clear, arrow down, go to the top, hit clear, arrow down. I'm going to enter in weeks 2, 4, 6, 8, 10 into the list 1. 2, 4, what did I miss? My 4. 2, 4, 6, 8, 10. List 2 is going to be the population or the y values that go next to it. Putting those into my list 2. Stat edit gets it in there. And then if I've got to write a quadratic equation, stat edit got me here. And then to go write a quadratic equation, I want to go into my stat and calculate menu. And I think if I'm right, I'm going to choose 5, which is a quadratic regression. Quadrag. So after my data's in there, I'm going to go stat, calculate, and I've been using the 4 or 5. Quadratic is what this one's going to be. So I'm going to press enter on my stat calc 5. Go through, set it all up. So my equation then is coming out of here as y equals negative 2x squared plus 24x plus 145. Just letting my calculator write that equation, and I absolutely expect that that's what you guys are going to be doing. I don't see the I see the vertex. I could write this all up, but why not use my regression? Now the last thing that they ask us here, there's a lot going on in this problem. The last thing that's asked of us here is estimate the number of spotted trout at the south end of the lake after week 14. So we need to let x equal 14. Go put it in wherever I see x and do the math for that. So I'm going to go right in.